Hello, students. So, we'll be continuing today with the thematic focus of this particular module, that is urban ecosystem assessment. And first thing we'll be discussing that why assessment matters, and especially now. Rapid urbanization crisis in India, all of us we are quite aware about it. 34% urban population, which is projected by 2050 to be 50%. Urban population will grow by 400 plus million. The largest urban migration globally is expected to happen in India. Current infrastructure deficits: 50 million of people lack safe water, 200 million are without sanitation. Critical environmental challenges: air quality. Cities like Delhi, Kanpur, Patna are always in news for it. And 1.2 million premature deaths annually. Similarly, in the waterfront, also, groundwater depletion is a big problem. The urban areas are losing the green space. Heat stress: cities experiencing 5 to 7 degree plus, that is the urban heat island impact. Vulnerable population, especially the outdoor workers, they are really at risk. So, in that particular scenario, what we will be discussing today, we'll be going for the overview of this urban ecosystem assessment, and we will be discussing four different tool sets: biophysical and spatial, ecosystem services and metabolic group, socio-ecological and vulnerability tools, and governance and indicators. It will follow case studies and way forward. Earlier, we discussed what these tools are. Now, we focus on how and why they are used in urban ecosystem assessment specifically. Urban ecosystem assessments is not about learning new tools only, which you have already been exposed to, but about learning to use familiar tools responsibly in complex urban systems. Potentials of tools and techniques, like for biophysical and spatial, we can always identify that it helps in baseline understanding. Functional interpretation we get from the services and metabolism related tools. Human system interaction, we find application in vulnerability and equity. Decision translation, governance, indicators, etc. And all these actually having a feedback loop into the refined spatial and biophysical analysis. What needs to do? Urban ecosystem focuses on assessment logic, choice and sequencing of tools, interpretation for planning and policy, and it has limitations and trade-offs in urban context, and we have also going to discuss a bit of it. Urban ecosystem assessment, by this particular phrase, what we try to mean. The purpose of this assessment is it will provide the analytical foundation for understanding cities as integrated socio-ecological systems. We discussed it for so many different lectures that it is neither a social one nor an ecological one. It's a combined one, socio-ecological system, rather than collections of isolated green or blue patches or human systems. Core objective is to reintroduce conceptual frameworks, which we have already discussed. We will be discussing from the perspective of this application side, and categories of assessment tools that support decision making. So, the dimensions we will be following are the biophysical structure for the structure part, ecological functions and services for the functional part, social use, exposure, and vulnerability, which will give us potential understanding of the interaction side, and governance and institutional capacity assessment, understanding the management aspect. The socio-ecological system framework, I hope all of us we do remember this one. The concept is cities are coupled system where human, that is the social system, and the natural, the ecological components, they interact reciprocally. I think all of us here need to really go back and look at module 4, 5, 6, 7, and especially some of the lectures as mentioned here. The framework The socio-ecological framework, as we know that Ostrom's group had proposed it, it talks about the resource systems, governance systems, and users, citizens, industries, vulnerable communities. Assessment implication: we cannot assess nature in isolation. We must assess the flows between these domains, that is, how land use policy alters flood risk. So, it is neither only the land use policy nor the risk separately. Systems theory and assessment, complex adaptive systems. We have discussed this as well when we discussed the systems theory. The cities exhibit non-linear dynamics and emergent behavior that complex adaptive system has already proposed. Feedback loops, some feedbacks are positive, like you have more of urban heat island, more people will be using the AC. Heat, waste heat will be more generated and it will be left in the environment, and higher UHI will come. So it's a reinforcement of that UHI phenomena. Whereas there can be a balancing feedback also. We call it negative, like water scarcity is there. You go for rainwater harvesting policy and it is implemented, groundwater will get recharged and stability will come back. So that's the way we know the feedback loops can help both in positive and negative way. Assessment goals: identifying the tipping points where ecosystem function collapses, like if more than 30% impervious surface is there, that will degrade the watershed health. So, we will be discussing these tools one by one: biophysical and spatial tools, baseline understanding. To quantify ecosystem structure and spatial configuration, we go for these biophysical and spatial tools. Primary tools which we use: remote sensing and GIS, land use land cover analysis, landscape metrics, fragmentation analysis, and blue green network mapping. In addition, physical survey is necessary for ground truthing. We always go for this ground truthing. These tools together describe the spatial structure of the urban ecosystem, its extent, configuration, and connectivity, which determines ecological functioning and risk. Individually, these tools they generate maps. Collectively, they reveal how urban form controls ecosystem performance, resilience, and vulnerability. The same spatial tools will allow us to infer multiple risks and services because urban ecosystems operate through spatial configuration. Urban ecosystems are shaped less by how much green or blue space exists and more by where it is, how it is connected, and how fragmented it is. So, this is very important that not only presence of them, but how they are present. That is also very important. Remote sense, as we know, satellite image, Sentinel, Landsat to classify urban surface types, NDVI, NDBI, NDWI, LST. These are the different major key index. Strong negative correlation between NDBI and NDVI we can find in Indian cities. Every 1% increase in built up area, we have seen at least 0.8% decrease in vegetation. This actually helps us in visualizing the invisible. So, false color composites FCC is a very important concept to be discussed. The idea is something like that: the satellites detect wavelengths beyond visible light, infrared. False color composites make these invisible wavelengths visible. So, standard false color composites like healthy near infrared, red and green. Healthy vegetation appears bright red, reflects near infrared strongly. Urban areas appear pale blue or cyan like concrete and asphalt. Water appears dark blue or black. And this actually helps us in distinguishing real vegetation from artificial turf or painted green concrete, which are essential for validating green cover. So that's the way the tools are helping us understanding the ecosystem and assessing it. Two types of UHI: surface UHI and the air level UHI, which is measured by weather stations, sensors. This shows ambient air temperature. Research indicates that more than 40% canopy cover at the block scale significantly mitigates daytime UHI. In the Indian context, we can say that fit for purpose methodology, combining remote sensing with ground sensors for heat action plans, are really effective. Landscape metrics, which is helping us in measuring the fragmentation. Let's say we have 100 hectares of forest in one patch, and we have also another scenario, 100 hectares in 100 tiny patches. Which is good, which is bad? They are not equivalent, as simple as that. So, FragStat, patch analysis, they help us in understanding it. As far as urban ecosystem is concerned, so patch density, largest patch index, mean patch size, clumpiness index, they are the indices which are going to help us in understanding and applying the FragStat software. Between 73 to 2022, in this 27 plus 22, almost 50 years, the built up area has increased in Bangalore by 51 plus percent, while green cover fragmented and declined by 26.28%. And we got this information once these studies are being done. Blue green network mapping. This helps us in mapping the physical and hydrological linkage between water bodies and vegetation. So it's not only spatial, it is also the functional side that comes with this particular mapping. Identify breaks in connectivity, like where the stormwater drains are blocked. Again, we come back to Bengaluru, that they have done this blue green networking, which has mapped the connectivity of Raja Kalu stormwater channels. And the goal was to restore the cascading tank system, ancient water management. That if one tank is having some additional water, that should cascade to the next tank. Nothing will go waste. GIS modeling of elevation and drainage versus the current encroachment was the major methodology. And it has identified 47 disconnected points across city which requires urgent intervention. So next one we'll be discussing ecosystem services and metabolic tools, and this is the functional interpretation of urban ecosystem. This is actually going to talk about the functional capacity. Urban ecosystems are not static assets, they are flow based systems whose performance depends on biophysical capacity and human demand. Two areas with similar green cover can perform very differently depending on metabolic intensity and service demands. If spatial tools show what exists, metabolic tools show whether it is coping and how it is coping. So, ecosystem services tools' purpose is to link ecological functions with human well being and economic value. The tools what you can use for this ecosystem services are invest, solves, urban metabolism, payment for ecosystem services, economic mechanism for conservation PES. And these are the tools which we have already discussed in depth in the previous modules. Socio-ecological and vulnerability tools is the next set where we will be exploring the human system interaction. Urban ecosystems do not benefit all populations equally. Again, we have discussed it. Vulnerability emerges where ecological deficits intersect with social exposure. Ecological degradation becomes a social problem when it aligns with vulnerable population. Urban ecosystem assessment fails if it stops at ecology and ignores the people. So, for that only, again and again, we are discussing that integration. So, the purpose is to capture human nature interactions, equity, and exposure. The tools are vulnerability mapping, participatory GIS, PPGIS, we have discussed it, which helps us in incorporating local or indigenous knowledge into official maps. Thermal inequity assessment, correlation of heat exposure with socioeconomic status, and carrying capacity assessment, maximum population and ecosystem can support. If you remember, we have discussed it in details in previous lectures. Vulnerability mapping, overlaying biophysical hazard layers with socioeconomic sensitivity layers. You can follow that process. Layer 1 can be the hazard. On top of that, we bring the sensitivity one, like slum, density, kacha housing, low income groups, elderly population, like that. And then the third layer is towards the coping capacity, that's the adaptive capacity, access to insurance, early warning system, emergency services, and mobility. So the output is the vulnerability hotspot maps, identifying where poor community face the highest combined hazard or sensitivity and the low capacity. Participatory GIS, incorporating local ecological knowledge into official maps. The objectives are ecosystem services perception, cooling zones felt during heat waves, areas perceived as flood safe or flood prone, recreational or cultural ecosystem services. These are the type of perception which we can get from the local people. Socio-ecological vulnerability, unsafe streets during extreme heat, pollution hotspots experienced by residents, access inequity to green or blue spaces. And the third objective we can talk about, that is the very important one, that is governance and planning feedback. Location of conflicts like encroachment, misuse, preferred sites for NBS interventions, community acceptance or resistance zones. Public participation in continuation. Methodologies can be community engagement, data points like secretaries, flood lines of 2015, such and such year, polluted stretch, gathering places, that can be data points from the public. GIS integration, convert participatory inputs into a spatial database. Validation, cross check with satellite imagery and biophysical data. Similar studies we can find in Cuttack, Nagpur, and many other cities. Slum dwellers mapped service deficiencies and flood history, and they revealed risks that satellite imagery missed, like clogged microdrains. So, assessment approach for this thermal inequity, which I was discussing, is the issue is the poor often live in the hottest parts of the city, where the vegetation is less and very highly dense settlements are there. Map the land surface temperature from satellite, overlay with socioeconomic status like data on income, housing quality, slum location will help to create this data. And then you calculate the correlation and identify thermal hotspots. Correlation found between high density or slum clusters with high LST in Delhi and Mumbai. Heat action plans must target these thermal hotspots for cool roof and greening. So these are very important, that when we are discussing the tools again here, we are also talking about its implication. Carrying capacity assessment like production, living, ecological space, PLES, environment, resources, infra, science and tech, socio-cultural, urban security, ecology, public services. These are the subsystems which can be assessed. And I think the carrying capacity concept, all of us we do remember the maximum population and urban ecosystem can support without degradation. The tools can be the comprehensive index evaluation method, coupling coordination degree model, obstacle degree model, gray prediction model, safe model, available. And once we try to understand the components that is actually being assessed, like available land, water availability, airshed capacity, etc. And the last group of tools we'll be discussing, that comes from the governance and indicators section. They help in decision translation. Institutional capacity to act, that can be assessed. Effectiveness of urban ecosystems depends as much on governance as on ecological condition. Well designed ecosystems fail without enabling governance structures. So, governance determines whether ecosystem knowledge becomes ecosystem action. So, it's a very important vertical governance and indicators. Indicators and index based tools, benchmarking and monitoring progress over the time is the major purpose. Many frameworks are existing, like City Biodiversity Index or Singapore Index. We will be discussing it in details later on. Climate Smart Cities Assessment Framework, we will also be discussing this one, which takes care of the green cover percentage, water body rejuvenation, permeable surfaces, and some of the indicators. And governance capacity frameworks, which assesses the institutional health, enabling ecosystem management. So the framework which we will be discussing, that is Climate Smart Cities Assessment Framework. Ministry of Housing and Urban Affairs, Government of India introduced it. Thematic areas which it can assess, that is urban planning and green cover, urban body rejuvenation, permeable surfaces, climate resilience. Climate resilience help us in understanding the disaster preparedness, flood proofing, heat action plans, and urban planning green cover, percentage green cover, accessibility of parks. These are the index. Area of water bodies reclaimed or restored for water body rejuvenation, and percentage of sponge city metrics, porous pavements, rain gardens are index for the permeable surfaces. The assessment type is self assessment or peer review, and then it goes for the star rating. National coverage is very impactful, over 100 Indian cities participating, enabling benchmarking and peer learning. Governance capacity assessment, the invisible ecosystem, one of the most important ecosystem to make sure that ecosystem functions appropriately. Biophysical health depends on institutional health. Best ecosystem tools fail without supporting governance, which we have discussed earlier also. Assessment metrics, legal, and the questions are wetlands or green areas protected by notification? What is enforcement? Fiscal, budget for maintenance, and not just capex. Multi year commitment or not. Cross sectoral, do water transport planning, health agencies share data and coordinate. And the community, is there participatory planning, grievance redressal mechanism exist or not? These are the type of question for this community assessment matrix. The tools are government capacity framework or environmental social governance assessment for cities, which are available on the government portals. And the last framework we'll be discussing, that is the DPSIR, driver rapid urbanization and population growth, that has to be understood, captured. Pressure, land conversion, groundwater extraction, sand mining. These are the index. State, lowered water level, fragmented green cover, air quality decline, etc. The status of that particular area. Impact, flooding, heat stress, health loss, and economic loss. Response is policy intervention. Blue green infrastructure guidelines exist or not. Usage, standard frameworks used by UN to structure assessment indicators. We can also find some notification from different governments, like in India, we have this EIA notification 2006. Legal requirement for development projects, it has said that if any construction projects are more than 20,000 square meter in built up area, they need environmental clearance. Similarly, for townships, if it is more than 50 hectares of area or 1,50,000 square meter in built up area, then they also need this environmental clearance. Required assessment components, Form 1 or 1A, they talk about land use change analysis, current versus proposed, water balance and groundwater impact, local biodiversity and habitat, air, water, noise quality, social impact, and community stakeholder analysis. Two case studies I'll be presenting. To elaborate this urban ecosystem assessment, first one is the Kolkata metropolitan area. The assessment approach is DMATL ANP model and CA Markov simulation. Built up area has improved, and this assessment has brought the findings like built up area has increased by 42%, agricultural land has decreased, now it is 28%, wetlands had declined to 35%. Most influential factors are land use change rate, built up density, and green connectivity, which has gone down. Western peripheral zones, rural to urban transition is very quick. Without intervention, the ecological security index is projected to decline by 35 to 45% by 2050, which is really alarming. Green infrastructure investment, sustainable land use planning, wetland restoration, these are critical actions for that particular city metropolitan area. Similarly, I will bring another case study, Bangalore fragmentation analysis, where FragStats landscape metrics have been utilized for the period of 73 to 2022. And the quantified results are built up area increase, green cover decline, largest patch of forest declination. Mean patch size has also declined from 62 hectare to 18 hectare, which is huge. Bangalore has over 650 species of birds and 18 endemic butterfly species. Assessment shows need for the green corridors and not just parks. The triangulation method. No single tool is sufficient. Effective assessment requires triangulation. Like if I am using remote sense GIS, maps the change. Where is green loss? Quantifies extent like hectares. Invest or metabolic flow analysis talks about the models, the function, how much carbon, water, food capacity was lost. PPGIS or other service, they validate the impact from the ground. Who is affected? What do communities value? Why does it matter? And lastly, the governance CBI identifies the lever. What policy needs changing? Who has authority? What is the budget? So, City Biodiversity Index or governance respond to these questions. So, you need to go for triangulation. Don't only depend on one, you can cross check it with another as well and get answer for many different questions. Emerging tools and future directions, real time digital twins, AI machine learning, blockchain for ecosystem markets, enabling payment for ecosystem services through transparent decentralized mechanism, nature based solution monitoring, like assessing the effectiveness on green infrastructure for multiple ecosystem services simultaneously. AI or machine learning, automated classification of LULC from high resolution imagery, prediction of tipping points. And digital twins will help us in integrating the IoT sensors, satellite data, ecosystem models for live monitoring and adaptive management. What is the opportunity lies in India? You can combine traditional water harvest method, staples and tanks with modern assessment tools to create resilient, culturally rooted solutions. So we can infer that urban ecosystem assessment is not about adding more tools, but about extracting different truths from the same evidence. The repetition of tools reflects the reality of cities. The same system must be understood structurally, functionally, socially, and institutionally before it can be transformed. So, with this is the summary slide, and these are the references. Thank you.